Okay, 2.4. Let's do something very basic. Back to maybe third grade, I think. 37 divided by 3. How do we set this up with long division? Inside the thing, yeah. 37 divided by 3. All right, next, what do? You ask yourself, 3 goes into, which part do you look at first? First part, 3, right? So 3 times what is 3? 1, and then what do? By 3, okay, multiply that thing by 3, or 1 by 3, and then where do you put that number? Underneath the 3. Thank you, Blake. Okay, then what? Move on. Wait, why do you put a 0? Subtract. We subtract. Okay, and then we move on. Yes, that would be 0. And then we move on to what? 7. And then what? 3 goes into 7 2 times. And then 6. And then minus, you get 1. Oh, right, there's a reason we're doing this. Yes, we have. Thank you. Good memory from last year. Yeah. Okay, so this is, we're reviewing this because it has to do with polynomial. Now let's kind of review the parts of this division problem. What is this part called? Did something. Huh? Dividend. Yes. The dividend. What about this part? What is this part called? Divisor. Okay, everyone knows this part. Remainder. Remainder, the leftover. And then the last part is 12. The answer to a division problem. Quotient. All right. Now let's review this or in a different way. How do I write this number? So basically we're saying 37 divided by 3, right? How do we write this result as a mixed number? Mixed number. How do you write this as a mixed number? Not an improper fraction, a mixed number? 12 and 1/3. Yes. Now, you may not know this. When I first saw it, I was like, oh, that's what I've been doing all this time? Okay, 12 and 1/3 means 12 plus 1/3. Did you know this? Yes. Okay, so this is another way of thinking about it. We have 12 whole ones and 1/3 of a whole. So basically 12 plus 1/3. Okay, so 12 and 1/3 means 12 plus 1/3. All right, now, how do I change this mixed number into an improper fraction? 12 times 3 plus 1, right? 12 times 3 plus 1. So we're going to, this is what I tell my Algebra 1 students if I were teaching them again. We go around the world. Okay, well, that's what they told me. They go around the world. So 3 times 12 plus 1. Okay, so 37 over 3. All right, we need to remember all that because that's how we're going to write polynomials. One is called the fraction form, the other is called the polynomial form. So let's go ahead and do it on the polynomial. We're going to divide this polynomial by a smaller divisor. So 3x cubed plus 5x squared plus 8x plus 7. We're dividing by 3x plus 2. All right, we always look at the highest degree versus the highest degree. So you ask yourself, 3x times what is 3x cubed? 3x times what is 3x cubed? Someone here. 3x times what is 3x cubed? X squared, very good. Now, where do we put the x squared? Do you guys know? On top of? On top of 5x squared. So we had to line up, so x squared goes here. Do you guys know what to do next? This row here. So 3x cubed plus 2x squared. We're just multiplying by that divisor. So take the x squared, multiply by every term of the divisor, and then put it here. Last row, what do we do next? Yes, very good, subtract. 3x cubed minus 3x cubed is 0, so leave that. 5x squared minus 2x squared is 3x squared. Back to you guys. What do we do next? Yeah, bring down the 8x. Yeah, we are going to do something with the 3x squared, but we're going to bring down the next term. All right, 3x. We're now looking at the next term. 3x times what is 3x squared? X. So we're going to multiply 3x squared plus 2x. All right. Sally, what are we going to do next?
8x minus 2x.
So we get?
6x.
Good. 6x. What do we do last? Someone besides Aaron and Alana. Huh? What do we do next?
Divide 3x.
Yes, but before then we have to multiply by 2. Yes, multiply by 2, but I gotta do something else with that 7. Yeah, bring down the 7. Okay, now we are gonna finish the problem. So 6x plus 4, subtract, we get 3. All right, the last thing we're going to do is we're going to write the answer in 2 forms, polynomial form and fraction form. We're going to start with the fraction form. Fraction form is the same as mixed number. Okay, it's the same idea as the mixed number. So if you were to write this as a mixed number, you would start with what? The remainder, the quotient, or the divisor? Quotient, yeah, quotient. So we're going to start with x squared plus x plus 2. 3 over 3x plus 2, but we're going to put a plus first because we have this thing plus, right? Just like the mixed number, we have a 12 plus 1/3. So plus, and then we're going to put the remainder over the divisor. Okay, so that's the fraction form. I'm kind of running out of room, so I'm going to write the polynomial form here, but you guys can probably keep it in the same place. Okay, polynomial form is going around the world. So change it into like an improper fraction. So what would you do? You gotta go around the world. So. Yes. So we're going to take the denominator times the quotient. So I'm gonna just write the quotient first. X squared plus x plus 2 times 3x plus 2 plus 3. And that's going to equal the f of x I had in the beginning, which is this part. Okay, so that is the polynomial form. Okay, let's have you guys practice one. Any questions so far? So those of you who are very, very quiet. Yes? Say that again? Yeah, sorry. So kind of like going around the world, you take the denominator times the quotient plus the remainder. All right. Let's go to the next one. Okay, next one. We're going to divide this by that. So let's write it out. 2x to the 4th minus x cubed minus 2. Those of you who remember this from last year, is this the right way to write it? No, what happened? Yes, because we are missing x squared and x, we got to put placeholders. Okay, so we have to put a plus 0x squared plus 0x and then a minus 2. If you don't do that, you're going to forget that you actually have some numbers that go into those terms. All right, please divide. You may want to talk to your partner or the people next to you because we are always subtracting and someone will forget to subtract and they will add. So kind of check on each other, make sure that your partner is doing it correctly. 2x squared, 2x to the fourth. So that's going to be x squared. Okay, so 2x to the fourth plus x cubed plus x squared. Subtract. The first term is going to be gone. Minus x cubed is minus 2x cubed. Minus x squared. So if you're going to feel like you're always going to get confused on that, you might want to put a minus sign in front and then change all the signs to remind yourself. Okay, so next one is going to be minus x. So that's minus 2x cubed minus x squared. They're all going to cancel, so you have 0x comes down. Am I doing this right? Oh, I'm sorry, I forgot that one. Minus x. That's a 0x, so minus x here. Okay, and then 0x minus minus x is going to be positive x. All right, from here, let's write the two forms. Fraction form is x squared minus x plus remainder over divisor. Polynomial form, you're going to go around the world. So take the quotient times the denominator and then plus the remainder. Are you guys okay? Yeah.
So we could just leave the polynomial form like that? We don't have to like distribute and add it?
No, because if you do, you're just going to get that dividend back. Okay. All right. You probably might just want to have, do it on your homework to practice so that you get used to the two forms and making less mistakes. Next, we're going to investigate the remainder theorem. I don't know if you remember this from last year as well. Not that one. Okay, remainder theorem says if you take a polynomial and you divide by a factor, let's say the factor is x minus k, then the remainder is f of k. So basically, if you divide by x minus k, well, if you divide by x minus k, that means you're saying the x value is equal to k. Then what you do is you just plug k into the function and you'll get a number. That number is the remainder. So let's see if that's true. We're going to find the remainder by dividing by this. Okay, so we're going to do it by long division first and see what the remainder we get. 3x squared plus 7x minus 20. We're going to divide by x minus 2. All right, go ahead and do that and see what remainder you get. Okay, once you solve it, what remainder did you get? 6? Yes. Now I'm going to show you that you can get the same remainder without actually doing that long division. Because according to the remainder theorem, all you had to do was put in that x value. So if x minus 2 is the factor, then x is equal to what number? 2? I always hear people whispering. Just have more confidence. It is 2. Okay, so the remainder theorem says if you put in 2 into the function, you should get 6. Where's the function? Yeah, f of x. Yeah, so put 2 in there and see if you actually get 6. Because if you do, it beats long division, right? It's much faster this way to get the remainder than actually doing long division. So did you get 6? Yes. So this is a much faster way to get the remainder, which we're going to need it for some other things later on. But let's try another one for practice. If you divide by x plus 1, what is the remainder? All right. What is the remainder? Yeah, negative 24. Let's say for some reason you divide and then you got a remainder of 0. What does it mean when you divide and you get a remainder of 0? So for example, if you take 10, you divide by 5, what do you get? What's the answer? 2. What's the remainder? 0. So what does that mean between the relationship of 10 and 5? If 10 divided by 5 is equal to 2 with no remainder, what do we say about 10 and 5? 5 is a what of 10? We don't say anything about 5 and 10. We usually say 5 goes evenly into 10, right? Something like that. Or 5 is a factor of 10. Like for example, 10, if you do a factor tree, right? You have 5 and 2. 5 and 2 are the factors of 10. Makes sense? So then if you take 10 and divide by any of its factors, you will always get a remainder of 0. So if you take a polynomial and you divide by a factor, the remainder is 0. What does that mean about that thing you divided by, that divisor? Yes, it's a factor. So the main idea is when you get a remainder of 0, whatever you divide by, that is a factor. Okay, so it means the divisor is a factor. All right, let's try this. Factor theorem. So factor theorem is kind of the same idea. So it says if you take this polynomial and it has this factor, then that means the remainder, where if you put in k as the x value, you should get 0 as the remainder. So if x minus k is a factor, then when you put k into the polynomial, you should get 0. Whew. Okay. Let's review synthetic division. Remember last year we had 2 kinds of division. We had long division, and then we had synthetic division. Synthetic division is actually the preferred way because it's faster, right? Okay, so we're taking this long dividend, we're dividing by x minus 3. In order to use synthetic division, we had to change this into a number. So if it's x minus 3, then x is equal to what? 3. All right, we're going to put 3 in here. Then we're going to take just the coefficients. 2 minus 3 minus 5 minus 12. And then what you're going to do is draw a line on the bottom. And then what I like to do is write a line in between the last 2 numbers that tells me after this line it's the remainder. Hopefully you kind of still remember from last year how to do this. The first thing you're going to do is you're going to drop down the 2. You don't do anything with it. Just drop it down. Yeah. And then you take that number and you multiply by whatever is in the box. So 2 times 3 is 6. And then you're going to put that number underneath the second number. And then this time you're going to add and not subtract. Add, not subtract. So it's 3. And then you do it again until you get to the last part where the remainder is. So 9, add 4, multiply 12, 0. What does that mean about this x minus 3 since I got it? Okay, so what does that mean about x minus 3 now that we have a remainder of 0? It's a factor. Good. Now let's look at this answer. So we have a remainder of 0. And what does all these numbers actually mean? Okay, that position 4, that is a constant position. So that's the number part. The next one is 1 degree up. And the next one is 1 degree up. So really we're talking about 2, 3, 4 is really 2x squared plus 3x plus 4. So that's the factor once we divide by x minus 3, that factor. Okay, so this would be the quotient. Okay. Let's look at the next question. Okay. Determine the factors of this polynomial using synthetic division. All right, so let's not use synthetic division first. Let's look at this polynomial and ask ourselves, can we actually factor? Is it possible to factor by grouping or anything you know? No, nothing. All right, so we have to try something else. Now this graph is the same as that polynomial. From this graph, or actually first thing, how many zeros are you supposed to have? 3. Okay, do you see 3 zeros here? Yes. What are those numbers? And something else, a little higher than 3, right? So what we can do is we are going to use synthetic division and divide those the zeros that we know, and then the remaining one will be the one we don't know. Okay, so we know that it has to be -3, so we can start with our synthetic division. Yeah, you can start with any one. It doesn't really matter. Okay, once you get the answer, divide out another one, which is x equals 1. The leftover will be the factor that you couldn't find. Okay, so go ahead and try that. Since you can see on the graph that -3 is a 0, your remainder has to be 0. If your remainder is not 0, you did something wrong. Okay, so this is kind of a way to double check. Okay, so from here, you're going to do synthetic division. 17, -51, 0. So you should get 0, right? Once you get 0, don't start from the beginning again. You're going to divide out the next 0, which is 1. So I would just start from here and then do that. And then divide out another 0. Because you're basically taking this polynomial and taking out a factor and then taking out another factor, and then the leftover will be whatever you couldn't find. Okay, so the next thing you do is take down the 5. 5 goes in here, -17, -17, 0. Okay, so now how do we write the 3 factors? Okay, we have 3 zeros, so that means we have 3 factors. Someone, give me one of them. X plus 3, yes? X minus 1, and the last one. Yeah, 5x minus 17. That's what 5 and -17 mean. 5x minus 17. All right, we're going to do the last one, and we're going to call it a day. So you're going to divide this by this. You're going to find the roots. You should get 3 roots. Okay, you should get 3 roots. Find the roots. So once you do the synthetic division, 1, 1, 1, 1, 1, 1, 0. Okay, so we get x squared plus x plus 1. They want you to find all the roots, so we obviously can see that 1 is a root. There are 2 more. The other 2 are stuck inside this polynomial. If you try to factor, you'll realize you cannot. So you have to use quadratic formula. So go ahead and try that. X is equal to -1 plus or minus square root 3 I over 2.